Hello guys, welcome back to my YouTube channel. So today we are going to solve day 25 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. So now without any delay, let's get started with today's problem. Problem number 515. Find largest value in each tree row. Okay. So in this problem, we have given the root of a binary tree. We have to return an array of the largest value in each row of the tree. Okay, so this is a classic problem of BFS, right? But interviewer may ask you for DFS approach as well. Okay, so first I'm going to solve this problem using BFS, and then I'm also going to explain the DFS approach as well, and the recursion, how recursion is going to work in DFS. Okay, step by step. So first let's try to solve this problem using BFS. Okay, so this is first level. Okay, so let's say this is level 0, right? In level 0 maximum is 1. Okay, this is my level 1, and in level 1 maximum is 3. Okay, and this is my level 2, right? And in level 2 maximum is 9, so I'm writing 9 here. Okay, in my array list. So this is going to my output. Okay, so nothing but level by level traversal we are doing, right? BFS, simple BFS. So how I'm going to solve this problem? So first of all, I'm going to create one queue, right? And in queue, first of all, I'm going to add the root. Okay, so I have added root. Okay, now after that I'm going to traverse inside my queue until it becomes empty. Okay, so here first of all, just check the topmost element in my queue. Okay, so topmost element right now is 1. Okay, and let's treat this as max value. Okay, right now max value. Okay, now for this one, add the children and remove this one. Okay, so for one, children are 3 and 2. Okay, and remove this one. Okay, from here. Okay, I have added the children for this one. Okay, so this is only max that I have. Okay, from the removed elements until now only one is there, so add this one in my array list. Okay, then after that take this topmost element as my max. Okay, for this index value. Okay, so take this as max. So here I have added 3. Okay, now for this 3, add the children. Okay, so children are 5 and 3. Okay, 5 and 3 are the children. Okay, so I'm removing this 3 and I am adding the children for this 3, that is nothing but 5 and 3. Okay, now take the next element. Okay, next element is 2, right? So this 2 is greater than this 3? No. So again my max is 3 only, right? Now add the children for 2. So 2 children is 9. Okay, so I'm going to remove this 2 and I'm going to add 9 here. Okay, this is done. So here I've added 3 for this level. Okay, now I move to the next level in which we have 5, 3 and 9. Okay, so first of all, treat this 5 as max. Okay, so here I'm adding 5 as max right now. Okay, now for 5, add the children. There is nothing, no children for 5. Okay, remove it. Okay, for 3, add the children and check if 3 is greater than this 5. 3 is not greater than this 5. Add the children for 3. There are no children for 3. Remove it. 9, so add the children for 9. No children's. Okay, and 9 is greater than this 5, right? So here I am going to operate 9. Okay, and there are no children for 9, right? So now my queue becomes empty, right? And for this level I am going to add 9 here. Okay, that is nothing but my BFS approach. Okay, so now let's write the code for BFS approach. Okay, so here first of all, you have to use queue, right? Since we are using BFS, right? So here first of all, let's create one list of integer. Okay, and let's name it as result and new array list. All right, now here one condition: if my root is null. Okay, if there are no elements. Okay, if my root is null, then simply return empty list. Okay, so I'm just going to return result from here. Okay, because my result is containing only empty array list as of now, right? So I'm returning result. Now we have to initialize queue. Okay, for BFS. So here you can write queue, and here inside this tree node, queue is equal to new linked list. Okay, right? And in the queue, first of all, add the root, queue dot add root. Okay, now we have to perform level order traversal. So here just check while my queue is not empty. Okay, while my queue is not empty. All right, and here inside this, first check the size of queue. Okay, because that many elements we have to remove and compare. Okay, as max. So queue dot size. Now after this, uh, just pick the topmost element. Okay, so tree node current is equal to queue dot peak. Okay, now create one variable max. Okay, and inside this just pass this value current dot val. Okay, now after that we have to process the current level. Okay, so for that run one loop for int I is equal to 0, I is less than n, I plus plus. Okay, and inside this we have to update max every time. Okay, max is equal to math dot max of max, and here inside this create one variable, update my current as. Okay, just update the current as. Instead of q dot peak, just remove this element. Okay, q dot pole. Okay, I have removed this element, and for this element, okay, I have to compare it with max. Okay, so here current dot val. Okay, and here just add the children for this one. Okay, so current dot left, if it is not equal to null, all right, then in that case in my queue just add current dot left, current dot left. Okay, and same way, if current dot right is not equal to null, okay, then in that case in my queue just add current dot right. Okay, so simple, right? And here after this for loop in the result, okay, in my array list just add the max value, okay, at this particular level. Okay, and in the end just return result, return result. Okay, that's it. So now let's run the code and see if there are any code issues. So the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? And we are somewhere here, right? So I hope that you guys are clear with this normal BFS approach. Okay, so this is the code for BFS approach. Okay, so now I am moving to the DFS approach. Okay, so let me just reset this code. So here if you see carefully, if I say that this node is at depth 0, okay, depth 0, okay, and these two nodes 3 and 2, okay, 3 and 2 are at depth 1, okay, and these nodes 5, 3 and 9 are at depth 2. Okay, so see the distance of 5 to 1. Okay, so 1 2, okay, 3 to 1 distance is 2, 9 to 1 distance is 2. Okay, so 3 to 1 distance is 1. Okay, depth 1. 2 to 1 distance is 1, so depth 1. Okay, so that is why I am writing like this. Okay, so depth 0, depth 1 and depth 2. Okay, so here what I'm going to do, first of all, we know that at depth 0 1 is there. Okay, depth 0, so I'm going to create one array list here as well. Okay, all right, so now here I'm going to check if the depth is equal to the size of this array list. So right now what is the size of this array list? 0, right? And this node is at depth 0 only, right? So in my array list I'm going to add this one. Okay, and I'm going to move to the left side of this one. All right, so now I am here at this node. Okay, so this 3 is at depth 1 and the size of my array list is also 1. Okay, so same, it is matching. 3 is at depth 1 and the size of array list is also matching, right? So in that case what we need to do, we need to add this 3 to our array list. Okay, now again I am moving to the left side. Okay, so now I am at this particular position. Okay, this 5 is at depth 2 Okay, and my size of array list is also 2. Okay, so what we need to do, we have to add this 5 here. Okay, so this is done. So here let me just write the index as well: 0 index, 1 index, 2 index. Okay, clear. So we have added this. Okay, now I'm again moving to the left side. There is nothing here. I'm returning null from here. Okay, done. Now I have to check the right side as well. I move here. Okay, there is null here. Okay, I'm just going to simply return here. Okay, now I backtrack to this 3. Okay, I have solved this completely. Okay, now I backtrack to this 3. Okay, so now 3 4 3 I have already checked the left side, complete left side. Okay, so now for this 3 I have to check the right side. Okay, so now what I am calling this 3 which is at depth 2. Okay, this 3 which is at depth 2. Okay, but the size of my array list is 3. Size is 3 here. Size is 3, right? And this 3 is at depth 2. Okay, both are not matching. So now what we need to do? So in that case I have to check. Okay, I have to check, but in my array list I have to check this depth. Okay, 2 index in. Okay, in my array list, check the depth. Okay, check the depth. Okay, now in this case, so at depth 2 what we have 5. Okay, and here at depth 2 we have 3. Okay, so I don't need to update because 5 is greater than this 3, right? So we are not going to make any changes in my array list. Okay, done. Now I am going to go back to this 3. Okay, so I have completely solved this side part. Okay, now I'm moving to this one again. Okay, so for this one we have already solved complete left side. Now I'm going to go to the right side of this one. Okay, so I move to this position. Okay, for this 2. So what I'm doing here, I am calling this node which is at depth 1. Okay, and size is not matching. Here size is 3 and this 2 is at 1. Okay, size is not matching. So what we need to check now? In that case we need to check this 2 index. Okay, this 2 index, this 1 index. Okay, this 2 is at 1 index, so we have to check 1 index. Okay, so 1 index is this, right? So here we have 2, this node value, and here we have 3. Okay, so 3 is bigger than 2, so no change. Okay, now after that we move to the left side of this 2. We are simply going to return null. Okay, nothing is there. Now after that we move to the right side of this 2. Okay, so now see carefully, we have 9. Okay, we have this node 9. So 9 is at 2. Okay, depth 2. Okay, and size is 3. Okay, not matching. This depth and this size is not matching. So what we need to do, we have to check this 2 index. So at 2 index we have 5, but here node value is 9. So what we need to do, we have to update this 5 with 9. Okay, so here I'm adding 9. Okay, done. Now after that, check its left, we are going to return null. Check this right, we are going to return null. Okay, and in the end we just come out of the loop. Okay, we have checked everything, right? We have checked left and right, everything, right? So in the end we are left with this list 139, and see 139 is my output. Okay, so this is nothing but my DFS approach. Okay, so now let's write the code for DFS approach. It's very simple. List of integer, and let's name this list as answer. Okay, and here inside this, in the answer, I'm just going to create new array list. Okay, and in the array list what I'm going to pass, integers only. Okay, so here just write integer. Okay, and yeah, that's it. And now just go this DFS method. Okay, so in the DFS method we have to pass the root and depth. Okay, root or nodes we are passing, and we are passing depth. So initially root is at depth 0, so here I'm writing 0. Okay, and from here I'm just going to return answer. That's it. Okay, so now inside this just write the code for DFS. So public void DFS. Okay, so what we are passing, we are passing tree node, node, right? And we are passing depth. All right, and inside this we are just checking if node is equal to null. Okay, so I have told you if my node is equal to null, then in that case we are simply returning return. Okay, now here I am saying one more thing. If my depth is equal to answer dot size, okay, so in that case we are simply going to add the value in my answer list. Okay, answer dot add node dot val. But if it was not matching, okay, if it was not matching, okay, so in that case what we were doing, we are just going to check that particular index. Okay, so answer dot set which index, the depth index. Okay, the depth is which at which index. Okay, depth index. So add this index, but we are going to pass math dot max of, okay, so the value which is already there in my array list. Okay, so answer dot get the depth, okay, that particular value over the current node value. Okay, so that's what we need to check. So here I'm going to write node dot val. Okay, that's it. Okay, and yeah, that's it. And here we are moving left and right, okay, two sides. So here dfs is dfs, okay, node dot left. Okay, so if I'm moving to the left side, so I have to increment my depth by 1. Okay, and if I'm moving to the right side, then also I have to increment my depth by 1. Okay, depth plus 1. Okay, that's it. This is the code for dfs approach. Okay, so now let's run it and see if there are any code issues. We'll try to fix that. So the test case has been accepted. Now let's submit it. So see, our solution is accepted, right? And the runtime is 0 milliseconds and we beat 100% of users with Java, right? And we are here, right? So I hope that you guys are clear with both the approaches, BFS and DFS. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.